Good morning, everyone. Today we'll be exploring a powerful mathematical technique for solving systems of linear equation called Cramer's rule. I'm Veni Melin, and together with my team members Hisha Akila Fadel Winata and Rizka Ulin, we'll guide you through this elegant method that uses determinations to find solutions to linear equation systems. What is a linear equation system? Let's begin by establishing what we mean by a linear equation system. A linear system is essentially a collection of two or more linear equations that all involve the same set of variables. There are two key characteristics that define linear equations. First, all variables must have a power of 1. We don't see terms like x squared or y cubed. Second, there's no multiplication between variables. We won't find terms like xy or abc in linear equations. The fundamental goal when working with these systems is to find values for our variables that satisfy all equations simultaneously. In other words, we're looking for a common solution that makes every equation in the system true at the same time. Matrix form of linear systems. Now, while we can write linear systems as separate equations, there's a much more compact and elegant way to represent them, using matrix. A system of linear equation can be written in matrix form as Ax equals to C, where A represents the coefficient matrix containing all the coefficients from our equation, X is a column factor of our unknown variables, and C is a column factor of constant from the right-hand side of our equation. So this is the example structure. This matrix notation is not just aesthetically pleasing, it's extremely useful for both theoretical analysis and computational implementation of solution methods. Understanding determinants. Before we can fully appreciate Cramer's rule, we need to understand a crucial concept, the determinant. The determinant of a square matrix A, written as delta or that A is a scalar value, just a single number that provides critical information about the matrix. Specifically, it tells us whether the matrix is invertible. Why does this matter? Here's the key insight. When delta is not equal to 0, matrix A is invertible, which means our system of equations has a unique solution. This is exactly the situation where Cramer's rule can be applied. However, if delta equals 0, matrix A is not invertible, and we cannot use Cramer's rule. In this case, the system either has no solution or infinitely many solutions. The determinant essentially measures whether our equations are truly independent or if some are redundant. A determinant of 0 indicates that our equations are somehow dependent on each other. What is Cramer's rule? Now we're ready to understand Cramer's rule itself. Cramer's rule is a mathematical technique specifically designed to solve systems of linear equations. It has several important characteristics. First, this rule is valid only when the system has a unique solution, which, as we just learned, occurs when the determinant is non-zero. Second, Cramer's rule is used when the number of equations equals the number of unknowns. If we have three equations, we must have three variables. The beauty of Cramer's rules lies in its approach. It uses determinant to calculate the value of each variable directly. This might sound abstract, so let's walk through a concrete example to see how it operates in practice.
Now I will show you how to solve using Cramer's rule. But first, there is one important condition we need to check. We can only use Cramer's rule when the determinant is not zero. So remember that. Let's start with step 1. We need to change the equations into matrix form. Look at these three equations on the screen. I'm going to split them into two parts, matrix A and matrix B. Matrix A has all the numbers in front of x, y, and z. We call these coefficients. Matrix B has the numbers on the side. We call these constant. Now, let's find the determinant of matrix A. Look at the step 2. Determinant A equals 2 times 3 minus 1 times 1 plus 1 times minus 1. When we calculate it, we get the value of 4. It's not zero, right? So we can continue with Cramer's rule. For the next steps, we're going to make three new matrices. Each time, we take matrix A and swap one column with matrix B. When we swap column 1, we get the new matrix A1 equals 711, 821, 912, and then we calculating the determinant A1, and that's the delta 1. That's 4. Swap column 2, we get delta 2, that's 8. Swap column 3, we get delta 3, that's 12. And now we have all the values we need. The final step is a simple division. X equals delta 1 over the main determinant. 4 over 4 we get 1, Y we get 2, Z we get 3. And that's it. X is 1, Y is 2, and Z is 3. That's Cramer's rule works.
Okay, so my friend have explained the theory of Cramer rule. Now, to make our work easier when solving linear equation with Cramer rule, we create a Python program that can calculate it automatically. So basically, instead of calculating determinant manually, which can be really time consuming and prone to error, we built this calculator to do all the work for us. So let me show you how it works. So when we run the program, this is what appears. First, you will see the main screen with the title Calculator Cramer's Rule. And then you will see there is an input field where you can choose your matrix size. And then if you don't input your matrix size, you should click the generate. Okay, so now let's say we want to solve a 3 by 3 system like the example in our presentation. So we can type 3 in the matrix size and then click generate. And now the program will create 3 by 3 grid of input boxes for us. So in the left side, we have spaces for our coefficient. And on the right side, we have equal sign. And then we have space for our constant. If you're done inputting the coefficient and the constant, you should click the Hitung button. The program will instantly show us the result. X equals to 1, Y equals to 2, and Z equals to 3. But that's not all. If we want to see how the program got this answer, we can click on lihat cara penyelesaian, which means view solution step. This is what will appear when you click the lihat cara penyelesaian or view solution step. So we won't get only the answer, but also the explaining how the program get this answer. One more important feature is if we input a system where the determinant is equals to 0, the program will show a warning message that say the system doesn't have a unique solutions. This prevents us from wasting time on unsolvable system. Well, I think that's all from us. Hope this video will help you to learn grammar rule. Thank you for watching this video and see you next time. Bye bye.